Hello children, we are doing class 12 physics, chapter 7 alternating current, important question. First one, a light bulb is rated at 100 W for 220 V supply, means 100 watt for 220 volt supply. Find first one, resistance of the bulb, B, peak voltage of the source, C, RMS current to the bulb. This is based on reader example 7.1. Now we are starting the answer. In the answer, light bulb is rated at 100 W. That is the power of the bulb. Power of bulb. P equal to 100 watt actually. For 220 V supply, so potential difference V. V is the potential difference, V is the virtual value of EMF also. The measurements taken by the instruments are considered as the virtual values only. So potential difference V is same as the virtual value of EMF. So equal to virtual value of EMF also I'll write one time. It is E suffix V or epsilon suffix V equal to 220 volt. Now we want to find out the resistance of the bulb. For finding the resistance of the bulb, R question mark. So we know the standard formula for the power of the bulb is P equal to V squared by R. Three formulas are there for the power actually. P equal to V squared by R. Next one VI. Now I squared R. Three formulas are there for the power. So here we want to find out the resistance. I'll take R to the numerator, P to the denominator. Or you can substitute at first. So 100 equal to V squared is 220 squared divided by R. So R will be equal to 220. R I took to the numerator. 220 into 220 divided by 100 I'll take to the denominator by 100. Two zeros will be cancelled. It will become 22 into 22 equal to 484. Unit of resistance is ohm. Here 0 and 0 will be cancelled. And again 1 0 and 0 will be cancelled. So you got 484 ohm. That is the resistance of the bulb. That was the A part of the question. Now we want to find out the peak voltage of the source. For finding the peak voltage of the source, virtual value of EMF you know. Virtual value of EMF or RMS, ERMS or EV, all of them are same only. And so I'll just write virtual value of EMF. That is E suffix V or epsilon suffix V, which is the same as the potential difference of the bulb. Potential difference across the bulb. Now you want to find out the peak value. Peak value, virtual value EV equal to E0 by root 2. That is the formula. So peak value will be E0 into root 2. You want to find out peak value of EMF. So peak value of EMF, peak voltage of the source. That is the peak value of EMF. I'll write peak voltage of source. Or in bracket, peak value of EMF. That will be equal to E0 equal to, will cross multiply, root 2 into EV, E suffix V. That is equal to root 2 into E suffix V is actually 220. We wrote again 220. So we'll get the answer 220 root 2. 220 root 2's value will be 220 into 2 times we wrote 220 root 2 only. So 220 into 1.414. When you multiply, you will get the answer. On multiplication, you will get the answer 311.08. Unit of that one is volt. Now, next one. C part is the RMS current to the bulb. RMS current. RMS current is IRMS or virtual value of current. To the bulb. That is IRMS or virtual value. So RMS current is also called virtual value. So IRMS is also equal to IV. We'll apply the Ohm's law. Ohm's law, according to Ohm's law, you know that one. V equal to IR. So V will assume as EV, not EV is the V is same as the EV only. So it will be IV into R. So what will be IV then? IV will be EV by R. IV will be equal to EV divided by R. So I am writing directly. So IV will be virtual value of current IV equal to EV divided by R. But we know what is EV. EV is 220 volt divided by resistance R already found 484 ohm. 484 ohm. So we'll write that one as 220 into, here I'll write 484 as 22 into 22. 122 will be cancelled, 22 into 10. With 2 stable you can cancel 2 5s are 2 11s are. It will become 5 by 11. So we'll approximate as 50. 11 into 4 is 44. Remainder will be 6. 11 5s are 55. 50 will come. 11 4s are 44. It will continue like that. So approximately equal to 0.45 unit of current is ampere.